Today we're going to begin talking about projectile motion. In order to do this, we need to understand what a projectile is. Well, a projectile is simply an object in free fall. In other words, the only force acting on it is the force due to gravity, or Fg. Imagine for a moment my friend Bob, who for some unknown reason likes to throw balls off of cliffs. From experience, we know that the path that the ball will take is a parabola. We might be interested in physics and finding out what the time of flight is of this ball, in other words, how long it's in the air for. We might be interested in knowing how far away from the base of the cliff the ball is going to land. This is the distance in the x direction. We also call this our range. Given the time, we might also be interested in the height at which the ball was thrown from. We would represent this as the distance in the y direction. Considering this object to be in free fall would be any time between when Bob has the ball in his hand and the ball reaching the ground. So let's pick a random spot in the path, and let's look at the free body diagram. Drawing the free body diagram of the ball, we always begin by drawing Fg, or the force due to gravity. Remember, we can also represent this as mg, the mass times the acceleration due to gravity. I'm now going to insert my x and my y axis. Keep in mind, because the object is in free fall, there are no other forces acting on this object. That means the sum of the forces in the x direction is 0 newtons, and the sum of the forces in the y direction is the force due to gravity. Let's start by looking at the sum of the forces in the x direction, which we know now is 0 newtons. From Newton's second law, we find that the force is equal to the mass times the acceleration. The acceleration must also be in the same direction. That means it is the acceleration in the x direction. The result is that the acceleration in the x direction must be 0 meters per second squared. In other words, in the x direction, this object will have a constant velocity. Now let's consider the sum of the forces in the y direction, which we know is simply the force due to gravity. Again, we can apply Newton's second law, and we find that the sum of the forces in the y direction must be equal to the mass times the acceleration in the y direction. Since the only force acting in the y direction is the force due to gravity, the acceleration in the y direction must be 9.81 meters per second squared, which we know is the acceleration due to gravity and is found on our reference table.